Okay, so looks like the final problem of the year is one I previously solved, but not so recently that I remember. Maybe. Anyways, see if we can do it. The last day where you can cross. There's a 1-based binary matrix where 0 represents land and 1 represents water. Given features row and column representing the number of rows and columns in the matrix respectively. Okay. Initially on day 0 the entire matrix is land, however each day a new cell becomes flooded with water. You're given a 1-based 2D array cells where cells at I equals R sub I, C sub I represents that on the ith day the cell on the row I, the cell at row R column C will be covered with water. 1-base coordinates change to 1. We want to find the last day as possible to walk from the top to the bottom, but only walking on land cells. Let's start from any row in the top and end at any cell in the bottom row. We travel in cardinal directions. Turn the last way where it's possible to walk. It's possible to walk from the top to the bottom by only walking on the land cells. Okay. So I think this is there's variations I've done with this where I think it's where you get to walk 1 day at a time or 1 land spot at a time, and each one increments the time. But here I think it just means it's the last day where there's any sort of connection between the top and the bottom. Any sort of connection between the top and the bottom. Yeah. Alright. So here's day 0, 1, 2, 3. Day 3. Okay. And it technically could not even be day 0, I think. Let's see. How can I tell when not be day 0? Oh, it's guaranteed? No. Rows between 1 and the number of rows, columns between 1 and the number of columns. Two less than or equal to row column less than or equal to 2 times 10 to the 4. So there's up to 20,000 rows. I'm trying to figure out where it states that it's always guaranteed to be. All the values of cells are unique. I'm trying to find where it can state that it's guaranteed to be possible on some day. Initially, okay, so it's based on just the fact that it all starts at 0. It's all land. Yeah, so it has to be at least capable on the first day. Okay. So what is the... So I vaguely recall doing this. I remember... Is this some sort of heap? No, is this some sort of queue? Some sort of process stack? So it's adding water to the to map each day. Adding water to the map each day. Do I need to find the path? I need to find the path. So it's going to cut off last day where you can still cross. It's going to cut off when, what's going to happen when it cuts off? Wonder if I can somehow come up with a way that it blocks the cutoff. Probably not, because the cutoff could be a diagonal. Like it could, if you run the water diagonally, here, 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 it's not really touching, the water's not touching adjacently, orthogonally. It does split up the paths. Two times 10 to the 4th. So if I created some sort of stack where I take the initial row position and add onto it the adjacent ones and just try to find a path each day. No, can't be right. The last day where it's possible. Last day where it's possible. So if I start with where the waters are, water, water, water. Start here. Go here. Start here, go here, go here. Water. Water. Start here. Doesn't work. What is the way to do this? Start here, go here. Start here, go here. It's the last day where it's possible. So it's almost like if I find the first day where it's not possible. First day where it's not possible. I don't think a binary search would work, right? First day where it's not possible. First day where you... So clearly this one is day 1. So there's 2 waters and it blocks every starting position. Blocks every starting position. The starting position traverse. Interesting. I wonder if I can go through every single path from start to end and see what's the last day it is on that path. Is that possible? Or is that too many paths? So for every position, cells that length is the same as rows and column. So wonder every possible path, find the slowest. For every possible start, find the longest. Find the latest. So work for every possible path, find the slowest way to get to the other side. Slowest way. Because the quickest way is not going to really help me, right? It has to be the slowest. So from here, like if I map each position to the day that the water reaches it. Map each position to the day that water reaches it. And then for every position I move towards the cell that has the higher one. I don't think that works. That doesn't seem, but the logic there is just not it. So this one, this one, this one, this one. So 0, 0, 0, 0, 0, 0, 0. And this thing breaks it. So if I assume going from here straight down, and then this thing gets bricked. So then I go back here, and then I see that this thing gets bricked. So I go here, here, here. here, or just here, here, then that thing gets bricked. So this thing. So do I keep on doing backtracking? Keep on doing backtracking? Because eventually there has to be I don't think I can do backtracking. I feel like the reason why something gets bricked and then trying to traverse and go around it might lead to some sort of local area of path discovery, but it's not necessarily the global longest living path. Slow decline. Slow decline. So you start by going on any start position. This one goes down, this one goes down. The last connected, huh? Connected. The last day was still connected top to bottom. Last day we're still connected top to bottom. 0, 0, 0, 0. And then breaks here. 0, 0, 0. 1, 1, 2, 2, 1, 3, 3, 2, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's some sort of day where it's no longer a connection. If I were to do what here? I guess if I were to do some sort of connected grouping. So maybe I can do a binary search. Connected grouping of everything at the top and everything at the bottom. Binary search for that day and check to see if on a certain day it works. Probably a somewhat optimized way of doing that now. check to see if a certain date works. So the binary search function would probably go how fast? It probably needs to be O of k, where k is the size of the grid. So 2 times 10 to the 4th. And then binary search that would be 2 times 10 to the 4th times log of 2 times 10 to the 4th. Guess, maybe? So for binary search, you just need to write a function that checks to see if on a certain day there's a path that goes from top to bottom. Is possible is generally the name of it. Is generally the name of the binary search function that we create. So something like, is it possible to do it on a certain day? And this is going to return a boolean. And it's true if possible to cross that day. Okay. So how would I quickly, or not quickly, but how would I do a check here? I think I probably need to map each cell to the day that it turns on, it becomes water. So I probably need to do some sort of mapping. So I think this would likely be for every, let's say, n is the number of cells, or maybe total is the number of cells. For every kind of day in that total. And if I should make this 1-based or 0-based. I don't know. Probably 1-based. So I need to make a water map, flood map, change map, flood map. This is going to be rows from columns, so I'm going to say -1, infinity, 0. Maybe it's infinity. So infinity times the number of columns for every row. It's correctly sized. And then for every day in total, I do row columns equal to cells at this day, and then flood map for this row and column. I think it should be -1, right? Just 1 indexed. Flood map for this row and column is equal to this day. So this would be 0 indexed. So like this first thing would be 0 here. Let's go ahead and put this out, make sure it works, or make sure it does something. row, not rows. I want to make these into plural, to be honest, but it is probably better if I keep the variable names the same. Int object not durable on line 10. Right, range total. Okay, so the flood map here is going to be day. I think that's correct. I think I wanted this to be 0, 1, right? Day 0, day 1, rather than 0, day 2. What's going on? Cells 1, 1. And cell row 0, column 1. Row 0, column 1 should be equal to day. Row column 1, 2. 1, 2, 1 minus 1 is 0, 2 minus 1. So 0, 1 should be equal to I think it should be 1. 0, 2. There's something in that many times the number of columns for every row. Cells of this day. Alright, let's go ahead and just print this out here. And it's going to be 1, 1, 1, 2. Okay, why is this 2, 1? Shouldn't that be 1, 2? Cells I is R, C. Oh, I'm looking at the. I'm a dum-dum. I'm looking at the wrong case. Okay. So, yeah, so 0, 0, 1, or 0, 2, 1, 3. Yeah, okay, that's right. This is 0, 1, 2, 3. Okay, so that's. I think the mapping is correct, or somewhat. Maybe I want it to be slightly offset than that, but I think it's fine. So, is possible on a certain day. So I think I want to basically do some sort of search. Search for, is it a search? I think I want to, yeah, I think what I want is to create graphs for every starting spot and see if that graph reaches an ending spot. And if it does, then that implies that there's a path. Okay, so for each starting spot, create a connected graph of land. If end spot is within graph, then implies, or then a path exists from top to bottom. Which way is short circuit? Short circuit, return true. Return false. after every starting spot is checked. Okay, I think I need a scene set. I need a scene set. Probably should be just a scene matrix of booleans, right? Scene matrix of booleans. So should be something like false times the number of columns for everything in the range of rows. Not sure if this is better or worse. Is this yeah, it's probably fine. Probably fine. So what I want to do here, so I want to iterate over the starting spots. So for everything in the range, for every column in range of the number of calls, and I guess I'll just use C. For every column index in range of the number of columns, I'll use this as my starting column index. The starting row index is obviously 0 for the starting row. I'll do something like if this is already seen, so seen at this row 0 column is true, continue, otherwise seen of 0 in this column is now true. I think I might want to do that. I could do that within the process stacking. So I think I need to have process. So somewhere in here there's going to be some sort of return true. I guess the process stacks should just be tuples of positions. So probably 0. Actually, if scene is of 0C is already seen, or if it's water, do I want to do water? Scene. Do I want to do water here? If this is seen or on this day there's water, or flood map at this position. So what is, so day, if I check day 0, if I check day 0 and it has 0 in it, what does that mean? Would I ever check day 0? I think I probably would, just to have something that's true. So day 0, so it floods on 0. This thing floods on day 0. So day 0 is like this arrow here. So it's land if it's, so it's land if it's less than or equal to. Oh gosh. I think this should be flood map if this thing is less than the day. So 0 is not less than 0. But it does match it, so if it's, so if I'm doing a day 200 and it floods on day 100, then it's less than. I'm checking day 0. and the flood map of that is 0, then it should be able to say that that's not flooded quite yet. So it doesn't, so it's not gonna break there. Okay, I think that logic is fine. So I put process is this tuple. This is open paths, open process stack. Stack of positions to process. And then while there's a process stack, let's go row. Ugh. Now I need another row column. Use C. Guess I can use C index. Ugh. Let's just do R index, rin, and column index. That's so bad. Process dot pop. Probably need a delta. Probably need delta. Delta array. So deltas would be going to left and right. 0, 1, 0, -1. Would I ever go up? I think I almost. Yeah, it would go up. Yeah. It's possible. I need to check up. Deltas is the change in directions from the current position. And then I probably need to do something like don't want to go out of bounds. Can make the whole sides all water. So if I make all the sides water, I think I would make it something like -1 here. So that means it by default it starts watered on day -1. And then I make the sides slightly bigger. So that means I can't go out of bounds if I go from a certain position to one of the deltas. It'll always go to water on the outside. So I think from there, so I have a current position. That's land. And then I'm going to do for every dr dc in range of, or in the deltas array, new row, new column is equal to the current row plus dr current column plus dc. And then if this is not water, so if flood map of this position is less than day, or it's already seen, right? Seen of nr and c is equal to true. Continue. say scene of nr_nc is now true, and I think I do process.append nr_nc. I think that might be okay. Actually, what's going on here? I guess maybe right here I should be checking if this is one of the end positions. So like if the row index is equal to the ending row, so this should equal row minus 1, then I know that this is going to be a correct path, so it's going to return true here. Okay. I think that's all I need. So for every starting position in the starting column, if it's already seen or if it's already flooded, skip it. Otherwise, add it to the stuff I've seen. Process starts with this position. Take out that position from the stack. If that position is actually an ending position, then return true because you found the path. Try to go through every neighbor. The neighbor hasn't been flooded or hasn't been seen. Add that to the stack. I think that might be right. And then return false. Return false. So it's not possible that day if this doesn't hit. Okay, so that's the binary search maybe. Flood map for every day, flood map on that day. Okay, so binary search is possible. So low days, I'll say day 0. High day is going to be day, the last day. I guess it can't really be the last day, but well, can it? No, it has to be something like the very latest would be something like the number of rows times the number of columns minus like if it's all clustered besides one last column, so minus the number of rows. I'll just say row times column. I think this should be -1. High should be impossible. That's fine. While low is less than high, mid is equal to low plus high divided by 2. And then say return value is equal to is possible at this midday if the return value is true. So it's possible at the halfway mark. So I'm going to try to find a higher day that's not possible, and so I think it should be low equals mid plus 1 is my sense. Otherwise I need to lower the cap, so high is equal to, let's say mid. Low equals mid plus 1 because the average, if this was like 0 and 1, it's going to check for 0. 0 works, then it checks for 1. Yeah, I think that was correct. And then it should return, it's going to work until it's going to go to the lowest impossible one, and then the highest possible one should be like low -1. Okay, I think there might be an off by 1 in addition to errors. Okay. Surprised that that passed. Wonder if I should try to find. No, whatever. Let's run it. Okay. Well, that's an answer. How surprising. Well, it's a hard problem, so I'm not sure how badly I want to try to optimize this. I don't recall doing this way. I mean, this process of checking binary search with a binary search on top of a graph, connected graph deal. I don't know if I did this before. I feel like I did the connected graph part before. Not sure. Not sure if it was attached to the binary search. Maybe it was. Is there any obvious optimization I can do here? So is there some sort of leverage play where I can leverage some facet of this? I mean, I think I could probably do something like the high value is row times column minus row, because it's like if you have a 10 by 10 matrix of positions, it's not like you can do 900 or there's 100 cells. It's not like you can do 100, but there's 100. If the water has reached 100 spots, then it's just not feasible. Like the last day would be roughly day 90, because you need at least the minimum amount of cells that you need that are still land would be the number of cells in a particular column, or which is the number of rows in the thing. So I think this should probably be row times column minus 1, which is equivalent to row times column minus row. Something like that. I think that's still correct. Might be off by 1, but maybe plus 1. Yeah, I think that's slightly more correct in terms of high value. I wonder if I can use low is equal to 1 here. I don't think that works, to be honest. Well, does it not? Maybe it does actually, because if low doesn't work, that might work actually. Low equals 1. You never really want to check 0 because you always, that's true, and then you're always just going to do low minus 1 here anyway. Maybe slightly more optimal. Okay, well, not much of a difference, if at all. Huh. I mean, I wonder if I got rid of the return value here, if it is possible in mid. There's no way this is any much faster, I don't think. I think it has to be something I do in my actual binary search function. I wonder if this is what I really want to do here. Create a 2D matrix scene. Seems like it might be pretty slow. I could just make a scene be a set. Could just make scene be a set. It'll be somewhat faster in certain instances, but then it's not always fixed. Alright, I'll try scene set here. Scene set is going to be an empty set here. If 0C in scene set with flood map of 0C is less than day, scene set dot add 0C. And here it's going to be if flood map at nrnc is less than day, or scene set or nrnc in scene set. Scene set dot add nrnc. Let's see if this is slightly faster, if at all faster. So you're creating out a fixed 2D matrix each time for a set of tuples, and it turns out to be significantly slower. Oh wait, I need to actually get rid of this. This is the whole point of that change. Okay. It is slower, not as slow as that second run, but so that wasn't the change I was hoping to do. Alright, going back to just the scene matrix. Flood map. Yeah, there's maybe some other way of traversing this that keeps track of things better. Obviously there's some solution that's 12 milliseconds in runtime. Impressive. So there's probably some way of tracking it on the fly, really. Tracking it on the fly. But that's going to rely on someone else being smarter than I am today. Could be me in the past, me in the future. Definitely not me today. Okay, so summary here. This solution is a binary search algorithm attached onto a kind of connected graph algorithm, connected graph algorithm for binary search. In this case, to find the earliest day, where or latest day where path exists. Requires creating a sum function that takes a day, takes an input day, and returns true, false for whether a path exists on that day. This function that determines if a path exists will iterate over all starting positions, basically top row positions, and create a connected graph of connected graph from those positions, and breaks/returns true if it reaches the bottom row, basically using, is this depth first search or breadth first search? I think this is depth first search. Using depth first search, traversal, and a process stack. Yeah, I think that's the summary of it. So you need to have a function that checks. I guess there is one other thing here. Also need to kind of translate the what's the thing called, the cells array into a kind of matrix of days, of blood days, where matrix at some row and column equals the day where that row column gets filled with water. So there's the stat translation. Did some slight optimizations. Generally, when you do the traversal from one position to the next position, in this case orthogonally, moving like one row over or one column over from some current position using an iterator over the delta row, delta column. Generally, you'll want a way to check that that new position, the new row, new column, is in bounds within the maximum row, maximum column. But if you have Python, instead of using conditionals on like 0 less than row, less than new row, less than the number of rows, and 0 less than column, or new column less than number of columns, instead of using conditionals to check that the new rows and new columns are within the bounds of that, you could not do the check, but also add kind of an out of bounds row and column that has some dummy values. In this case, I created the flood map to include that dummy row and dummy column by inserting it on the sides. And so if the row goes backwards into -1 row or forwards into the max row, column goes into the negatives, or column goes to the last column or after the last column, then it's going to be the value of that flood map there is going to be -1, which means it starts at flooded before day 0. I'm actually really surprised that this didn't have to screw over less than day part or less than or equal to day part. I wasn't sure about the correct plus or -1 day logic. Anyways, time complexity for this. This is going to be time complexity for this. This is going to be O of RC log RC, where R is the number of rows and C is the number of columns. The binary search function the binary search portion will take O of log k time, where k is the maximum number of maximum day, or the upper bounds of day to be searched. In this case, it's going to be approximately the number of rows and number of columns. Here k equals RC. And then each check using each check of a certain day using the isPossible function will take O of RC since iterating over the positions of the map to determine the connected graphs will possibly iterate over each position once. I can guarantee that because each position there's a check on whether or not I've already checked this position. So it's going to be turned to true if I see this position. You only check once, and in the worst case, it takes you looking through every position to determine that it's going to be returning false. Okay, and then space complexity is going to be O of RC to have the scene matrix for checking if a position has already been checked. Alright, cool beans.